Good morning. Today we are going to see a topic Burgle's approximation method in the subject discrete structure and optimization technique. What is meant by a transportation problem? Transportation problem is a type of a linear programming problem. Here the supply and the demands are the sources and the destinations respectively. In order to reduce the total cost, we have to balance our problem. There are two types of problem. One is balanced and unbalanced problem. If the total number of supply and the total number of demand is equal, then the problem is said to be a balanced problem. If the total number of supply and demand is not equal, then the problem is said to be an unbalanced problem. We have to add a dummy row or column to make it balanced. There are so many methods to solve a transportation problem: NWC method, least cost method, and Burgle's approximation method. Those two methods are already seen. Here I am going to see VAM method. Burgle's approximation methods algorithm identify the two least cost in each row and column of the given cost matrix and then write the absolute row and column difference. These differences are called as penalties. Identify the maximum penalty and assign the corresponding cell which is having a minimum supply or demand. If two or more columns or rows have the same maximum penalty, then we can choose one among them as per our convenience. Step 3. If the assignment in the previous satisfies the supply at the origin, delete the corresponding row. If it satisfies the demand at the destination, delete the corresponding column. Step 4. Stop the procedure if supply at each origin is 0. That is, every supply is exacted and demand at each destination is 0. Every demand is satisfying. If not then repeat the above step. My first problem is 327675232545. Sum of my supply and the demand are 50, 60, 25 and 60, 40, 20 plus 15. If we add these supply and demand separately, we will get the value as 135. So my problem is balanced transportation problem. Now I am going to subtract it by taking a two minimum values in my row. So that is called as a row difference. My two minimum values 3 and 2. If I subtracted it, I will get the value as 1. In second row also I am having 2 and 3. If I subtracted it, I will get 1. In my final row I am having two minimum number is 2 and 4. If I subtracted it, I will get 2. Similarly for column difference, my two small number is 3 and 2. 2 and 5, 4 and 2 and 3 and 5. Of these row differences, I am going to select a maximum penalty. My maximum penalty is 3. Of this maximum penalty, I am going to select a minimum supply or demand. My minimum supply is 40 and my minimum value is 2. So if I subtract 40 from 50, I will get the value as 10 in my supply, so that the row will be vanished. In my second, I am going to subtract by taking a two minimum value. Here my minimum value is 3 and 6. I will get the difference as row difference as 3. And finally, I will get the row difference in the second row as 1, 2. In column difference, the second column will change because we crossed out that. So we will get 1, 3, 2, 2. Here the maximum penalty is 3 and 3. We can cancel it both. Our penalty value is 0 in our row, and so I am going to select the row. Of these row, I am having 3 as my smallest number. If I balanced my row and supply, I will get the value as 10. So the supply will be cancelled out and the demand will alone stay back. So in the third column, I will get the row difference as 0, 1, 2. Third column is 5, 0, 2, 2. Of these, the maximum penalty is 5 I am allocating my cost to 2. So the problem is balanced by allocating 25 to my cost and subtracting 25 to the supply. And my fourth row difference is 0, 1, 0, and fourth column difference is 7, 0, 2, 2. If I am selecting the maximum penalty is 7, so that the problem is balanced by subtracting 25 minus 25, and in my right hand side I will get 60 minus 25. Finally my difference is 0, 1, 0, 0, 0, 2, 3. If I balanced it I will get 15 minus 15, and 35 minus 15 is 20. Finally the number 2 alone will stay, so that 20 and 20. What we have done in our NCM and northwest corner rule, the same we have to do it here also to find the total cost. That is the multiplication of the allocations and adding up together we will get the total cost. Here the total cost is 420, so my total cost for my problem is 420. This is another method to find a maximum profit. Thank you.